Here are some problems to which we can apply those theorems that we just looked at. So for the first one, cubic equation should have how many roots? Yep, well, they tell you right here, it should have 3. There are going to be 3 roots, fundamental theorem of algebra. This is x to the third, it's going to have 3 roots. So they gave us one root is -1, and the other root is all of this. That's all one answer. So automatically, because of the square root here, we can tell what the third root is, because it has to be the conjugate of this one. So automatically the third root is going to have to be the square root of 3 minus 2i. The exact same expression, except change the sign in the middle. For number 2, quartic equation. Quartic, we'd expect how many roots for quartic? Well, quart does mean 4, like 4 quarters in a dollar, 4 quarts in a gallon. So we should have 4 roots. They gave us 2 of them. So we should be able to use the conjugates and find the other 2 roots. Well, this one's going to be very similar to the one above it. It's going to be the exact same thing, but change the sign in the middle. That's the only sign we change. So this will still be a -3. It will still be square root of 2, but it will be minus square root of 2. So now we have 1, 2, 3 roots. We can take the conjugate of this if we think of it as 0 minus 2i. So then its partner would be 0 plus 2i, which they would probably just write as positive 2i. So now we have a pair of imaginary roots here, a pair of square roots here, and we need all 4 of those to finish out the quartic equation. Number 3, they want the sum and the product of the roots. Well, if you remember, the sum of the roots is a fraction. It's going to be the opposite of b divided by a. The product of the roots is also a fraction. It's going to be the constant at the end divided by the leading coefficient if it's an even degree. But if we have an odd degree polynomial, then it's going to be the opposite of k over a. And they want us to find both of them. So we have 2x squared plus 5x minus 3 equals 0. The sum of the roots should be the opposite of b over a. So the sum is going to equal -5 over 2. The product of the roots well, is that going to be the constant divided by the leading coefficient or the opposite of the constant divided by the leading coefficient? This is an even degree, so just go with whatever that constant on the end is divided by the leading coefficient. For part B, so we have 4x cubed minus 2x squared plus 5x minus 6, all equals 0. And they want the sum of the roots. Well, these are going right straight down. And I made a mistake here. This is a 5x. So this would go x squared and x. This goes x cubed, x squared, x constant. So we're not missing any terms. And the sum is just going to be the opposite of this over 4. And they would probably expect us to reduce that to 1/2. So this cubic equation with 3 roots, whatever the 3 roots are, they add up to 1/2. And the product is either going to be the constant over the leading coefficient or the opposite of the constant. Well, this is a cubic, so it's going to be the opposite of the constant, because if it's odd degree, you change the sign on the constant. So that would make this the opposite of negative 6 over 4, which would become 6 over 4, which would become, you could say, 3/2 or 1/2. Part C, we have x to the 4th plus 2x cubed plus 3x squared. And that's it. So the sum is going to be equal the opposite of b over a, or just negative 2. Whatever these 4 roots are, when you add them up, they add up to negative 2. And the product is going to be the constant on the end divided by the leading coefficient. Well, there is no constant down here. So the product would be 0 over 1, which is just 0. Whatever these 4 roots are, when you multiply them out, it multiplies out to 0. So one of the roots has got to be 0. And finally for D, well, this is pretty short. So the sum is going to equal the opposite of the second term coefficient divided by the leading coefficient. Well, the second term in here ought to be 0x to the 4th. So that would be 0 over 1, which is just 0. These 5 roots all add up to 0. Product well, it's either going to be the constant divided by the leading coefficient or the opposite of the constant. This is an odd degree, so it's going to be the opposite of the constant. It's going to be negative 32 over 1. So whatever these 5 roots are, they add up to 0, and they multiply out to negative 32. For number 4, we're going to skip because we just did it a few minutes ago. Why a cubic equation has to have at least one real root. Because it's n behavior headed in opposite infinities, it has to cross the x-axis. So number 5, we'll just move on to that. Quartic equation. What does the graph of a quartic equation look like? Or what can it look like? Maybe this W shape? Or if it was a negative, kind of like an M shape? They're saying that it doesn't necessarily have to have any real roots. Well, I don't know. So that one does. But this one doesn't. It does not have to cross the x-axis. Since both ends are headed in the same direction, we don't necessarily have any real roots. So looking at it with a graph makes it easy to understand where they came up with this theorem. And that's it for the theorems for the moment.